Let me record a video so that it will be helpful for you during the revision purpose. So the theorem that we are going to discuss in this class is the Pythagoras theorem and the converse of Pythagoras theorem. So let us start with the Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. This Pythagoras theorem, okay, it says that in a right triangle means a triangle in which one of the angle is 90 degree. That's a right triangle. Okay. So if we want to construct a right triangle, then we construct in this way. Suppose PQR is a right triangle, right angle at Q. So that is how we construct a right triangle. A triangle in which one of the angle is 90 degree. Now in a right triangle, we have always the longest side. There is always a longest side. And how to identify the longest side? In a right triangle, the side which is opposite to your right angle. Here your right angle is Q. Q is at the right angle, right? 90 degree is at Q. So in a right triangle, the side which is opposite to your 90 degree angle or the side which is opposite to your right angle is the longest side. So look at this figure. Here PQ is the side which is opposite to your right angle, right? The side here, the side PR, here the side PR is opposite to your right angle. This is your right angle. So the side PR is opposite to your right angle. So this PR will be known as the longest side. And there is a name for the longest side. We call it as hypotenuse. Okay, we call it as hypotenuse. So this Pythagoras theorem says that in a right triangle, this right triangle, the square on the hypotenuse means the square on the longest side is always equal to the sum of squares on the other two sides. That means if we write it, if we express it mathematically, then the square on the longest side. Here PR is your longest side. How PR is your longest side? How did we identify? The side which is opposite to your right angle is always the longest side. And it has a name, we call it as hypotenuse. Okay, the mathematicians, they named that longest side as hypotenuse. So in a right triangle, the square on the hypotenuse, so PR square, the square on the hypotenuse is equal to the sum of squares on the other two sides. That is PQ square plus QR square. So that's very simple. So if question is asked, state and prove Pythagoras theorem, then if you write this statement, then you get 1 mark. Is it okay? Now how to write the statement? Pythagoras theorem states that in a right triangle, you must always start with the word in a right triangle. Okay, in a right triangle, the square on the longest side is always equal to the sum of squares on the other two sides. That's the statement of Pythagoras theorem, and that statement is going to fetch you 1 mark if it is asked in the examination. Okay, so let me write this down. Okay, so we are going to write the statement for Pythagoras theorem. This states that Pythagoras theorem states that in a right triangle, in a right triangle. Right triangle. Right triangle means a triangle in which one of the angle is 90 degree. That's a right triangle. So in a right triangle, the square on the longest side, the square on the longest side, we have a name for the longest side, which we call it as hypotenuse. So the square on the longest side, which is known as your hypotenuse, the square on the longest side, that is hypotenuse, is equal to the sum of squares, is equal to the sum of squares on the other two sides, on the other two sides. Okay, so that is the statement of your Pythagoras theorem, and so we are going to prove this Pythagoras theorem. We are going to prove this Pythagoras theorem. So for that, I'm going to draw a right triangle. All that is given is your right triangle, and using that right triangle, you must prove the following condition. Is it okay? That is, square on the longest side is equal to the sum of squares on the other two sides. Is that all right? So I'm going to draw the right triangle over here. So okay, let me draw the right triangle. You can draw the right triangle in any manner we like. This is how I have drawn. This is how I have drawn. So this is a right triangle, namely A, B, C, in which angle B is 90 degrees. So I have drawn a right triangle ABC, in which angle B is equal to 90 degrees. So this is a right triangle ABC. Okay, so a right triangle ABC in which angle B is equal to 90 degrees. So we have constructed a simple right triangle ABC in which angle B is equal to 90 degrees. Now let me start with the proof of this Pythagoras theorem. Let me show you how this Pythagoras theorem is proved. Okay. So proof of the Pythagoras theorem. Proof. So what is given is, okay, what is given? A right triangle ABC in which angle B is equal to 90 degrees. That is all that is given. Okay, this is all that is given. So, given a triangle ABC, okay, given a triangle ABC in which angle B, angle B is equal to 90 degrees. So that is all. Okay, what is given. Now to prove that, what do you want to prove? You want to prove that if it is a right triangle, then the square on the hypotenuse should always be equal to the sum of squares on the other two sides, right? It is all we want to prove. Now, in this right triangle, can you identify which one is the hypotenuse? In this right triangle, can you identify which one is the hypotenuse? Remember, the side which is opposite to your right angle is always the longest side for the hypotenuse. I have two comments. Yes. Okay. No. Some students, okay, you are having so much difficulty. You are having so much difficulty identifying the hypotenuse. I told you the side which is opposite to your 90-degree is your hypotenuse. So which one is that? Which is the side opposite to your 90-degree? Which is the side opposite to your 90-degree? Yes, AC. AC is the side opposite to your 90-degree. AB is in contact with 90-degree. It is not hypotenuse. BC is in contact with 90-degree. It is not hypotenuse. AC is the side which is opposite to your 90-degree angle. That's the hypotenuse. Is that all right? So if you are still confused with it, then I think you must the only thing that you need to remember is the side which is opposite to your 90-degree is your right angle. Is it all right? Oh, the side which is opposite to your all the there is a so ABC square is equal to the sum the other two on sides are AB and so AB square plus 1 to 2. Okay. Now, in order to prove this is not enough. So what I'm going to do is we are going to draw something apart from what is given. That will be your construction. What is given? It is not construction. So construction you do here is from this we this okay from the vertex B I have drawn a line say BD which is perpendicular to AC. So what I've done here is draw BD perpendicular to AC. Is it okay? That is the construction that we require. Now altogether there are three right triangles here. Can you identify them? Altogether there are three right triangles. The first right triangle is the biggest, ABC. Okay, the first right triangle is the biggest, ABC. And then there are two smaller right triangles. One is ADB. This one is your first smaller right triangle. And the other one is CDB or BDC. BDC. Is it okay? So in this figure, altogether there are three right triangles. One was your given right triangle, the bigger one. ABC is the biggest right triangle which was already given. While doing the construction, we got smaller two right triangles, ABD, and the other one, BDC. Is it okay? Now what I'm going to do is, I'm going to take, out of the two, I'm going to take a smaller right triangle and then the bigger right triangle. There are two smaller right triangles. One is ABD, one is BDC. This is your first smaller right triangle. This one is your other smaller right triangle. And we have the bigger one, ABC. Is it okay? So out of the two smaller right triangles, you choose any one of them. And then you take the bigger one. Is it okay? And you show that they are similar to each other. Is it okay? You show that they are similar to each other. Now C class, very interesting here. I will give you a proposition, or we can say a lemma. And that lemma, that proposition is going to help us to show the similarity of triangles. Okay? A very important proposition, a very important lemma. We can call it as proposition. Now, you listen to this very carefully. This is a right triangle. This is a right triangle. Say PQR, PQR, in which angle Q is 90 degrees. I have drawn a simple right triangle PQR in which angle Q is 90 degrees. In that case, this PR is your hypotenuse. Because PR is opposite to your right angle, so known as the hypotenuse. From this Q, you draw a line perpendicular to PR. Let me name it as M. You draw PM perpendicular to P. You draw QM perpendicular to PR. Now what I have done here, plus you listen to me very carefully. I have drawn one perpendicular from where? From where? From Q. From Q. I have drawn a perpendicular from Q. This Q is the vertex of a right angle, right? See, in this triangle PQR we have three vertex P, Q, and R. Q is the vertex of a right angle, right? The right angle is drawn at Q. So Q is the vertex of a right angle. Now you listen to me. If a perpendicular is drawn from the vertex of a right angle up to the hypotenuse, see, you have drawn the perpendicular starting from Q up to the hypotenuse, right? So if a perpendicular is drawn from the vertex of a right angle to the hypotenuse, then the right triangles obtained. See, the triangles obtained. You have obtained two triangles, right? So the triangles obtained on both sides of this perpendicular QM are similar to each other and with the whole triangle. Are you following that? Are you following that? Let me repeat it again. Let me repeat again. Let me draw a simple right triangle PQR, right angle at Q. Then this Q is the vertex of your right angle, right? See, I have drawn a simple right triangle in which the right angle is at Q. Now this triangle has three vertices, P, Q, and R. This Q is the vertex of the right angle. See, I have drawn the right angle. I have drawn right angle at Q. So Q is the vertex of your right angle. Q is the vertex. This is a vertex. This is also a vertex. This is also a vertex. Right angle is at Q. So Q is the vertex of right angle. Is that all right? Q is the vertex of a right angle. So Q is the vertex of a right angle. Now you see, class, you see, Q is the vertex of your right angle. Now from this vertex Q, you draw another line which is perpendicular to the hypotenuse. From this vertex Q, you draw another line which is perpendicular to the hypotenuse. You can name it as QM. So this PR is your hypotenuse. This PR is your hypotenuse. So what I have done here, from the vertex of a right angle, I have drawn a perpendicular to the hypotenuse, right? Okay. Now the proposition says, if a perpendicular is drawn from the vertex of a right angle up to the hypotenuse, then the triangles obtained, see, I have obtained two small triangles, right? The triangles obtained on both sides of the perpendicular. This is your perpendicular. So I have obtained two triangles on both sides of the perpendicular, right? So the triangles obtained on both sides of the perpendicular are similar to each other and to the whole triangle. Are you following that? That means triangle PQM is similar to triangle QMR, and it is also similar to triangle PQR. Is it okay? So if a perpendicular is drawn from the vertex of a right triangle up to the hypotenuse, then the triangles obtained on both sides of the perpendicular are similar to each other and to the whole triangle. This is a concept that we are going to apply in this Pythagoras theorem. Is it all right? In order to prove Pythagoras theorem. So you please make a note of this, okay? If a perpendicular is drawn from the vertex of a right angle up to the hypotenuse, then the triangles obtained on both sides of the perpendicular are similar to each other and to the whole triangle. Is it all right? Yes. Is it done? Is it done? You please make a note of this one. Please make a note of this one, this proposition, and once you are done, we shall proceed with the Pythagoras theorem. Is this clear to you, class? I hope this is clear to you. Okay, so if you are done, I'm going to rub this one, and let me proceed with the proof of Pythagoras theorem. Let me proceed with the proof of Pythagoras theorem. Now, class, see, here also what I have done is, ABC was your given right triangle, right? What did I do? I have drawn a perpendicular. From the vertex of the right angle up to the hypotenuse, right? Then what happens? We have obtained two triangles on both sides of this perpendicular, right? Is it okay? So according to this proposition, if a perpendicular is drawn from the vertex of the right angle up to the hypotenuse. See, B was the vertex of the right angle. AC is the hypotenuse. From this point up to the hypotenuse, I have drawn another perpendicular, right? So since in this triangle ABC, we have drawn a perpendicular from the vertex of your right angle up to the hypotenuse. And so, the triangles obtained on both sides of this perpendicular will be similar to each other and with the whole triangle. That is what I'm going to write. Is it okay? Yes. So proof. We have triangle ADB. Triangle ADB is similar to triangle BDC. Is also similar to triangle ABC. Why? Because if a perpendicular is drawn from the vertex of the right angle up to the hypotenuse, then the triangles obtained on both sides of the perpendicular are similar to each other and to the whole triangle. That is the reason. So we need to write, if a perpendicular is drawn from the vertex of a right angle to the hypotenuse, then the triangles obtained, then the triangles obtained on both sides of the perpendicular are similar to each other, and with the whole triangle, So this is the reason why the three triangles are similar. Is it okay? And this is the most important reason for showing similarity of triangles. See, every Monday, Tuesday, Wednesday, we have maths online class from 9 to 10. So whether you have class tests, whether you have examination, whatever test, whatever class, other classes you have, I do not care, because this is strictly, okay, from Monday, Tuesday, Wednesday from 9 to 10, it is always maths class, so you have to attend maths class. And if you start commenting that you have a class test or whatever it is, I'm going to remove you from the group. That is not my problem, okay? Every day, you must tell your teachers, you must tell your other teachers that every day, Monday to 10, Wednesday, you have maths online class from 9 to 10, so there should be no other class tests. Is it okay? Or there should be no other online classes. This is strictly maths, okay, online class, Monday, Tuesday, Wednesday, from 9 to 10. So if you start commenting, okay, on the chat that you have this test, that test at this particular time, then you are out from the group. You must inform your other teachers that it cannot be done because we have maths online class. So Shisa Mella, I'm going to remove you from the group. Sentitula also. Okay, I'm going to remove you from the group. Sentisola and Shisa Mella. Okay, so you are going to be removed from the group because of this behavior. Now what I'm going to do is, we have three triangles here. The first one is the bigger right triangle ABC. Next, we have smaller two right triangles. One is ADB, and the other one is BDC. Okay, we have three triangles here. The first one is ABC. Next, we have smaller two triangles ABD and BDC. Now, all of them are similar to each other, but we cannot take these three triangles at a time. So I'm going to take two at a time. I'm going to take two triangles at a time, but make sure that the bigger triangle is always present. Okay? Now what I'm going to do, I'm going to choose this smaller right triangle, ADB, and I will take the bigger one, ABC. Okay, and I'm going to draw them here. There are three similar triangles here. There are three triangles. They are similar to each other. We have already seen that. Okay. Now what I'm going to do is, I'm going to take two triangles at a time, but make sure that the bigger triangle ABC is always present. So let me start by taking this smaller triangle ADB and the bigger one AD. Okay. So let me start by taking this smaller triangle ABD. This is A, here is your B, this is your D. At D we have 90 degree, at D we have 90 degree. And you take the other one, ABC. Take the larger one, ABC. So this one is your larger right triangle, ABC, in which this angle B was 90 degree. Now we have already seen that they are similar to each other, right? So since triangle ADB is similar to triangle ABC, we have seen above, they are similar, okay? I have written why they are similar, okay? We have shown that they are similar, so I will just directly say that this ADB is similar to ABC. Now class, we have learned that in the previous class we learned that if two triangles are similar, then what? Their corresponding sides will be in proportion. Meaning ratio of their corresponding sides will be equal. That is what we have learned while doing the basic proportionality theorem. That is what we have learned while doing the areas of similar triangles theorem. Okay. So what did we learn? In the previous class, what did we learn? If two triangles are similar, then what happens? Ratio of their corresponding sides will be equal. Therefore, from this triangle, if we take the hypotenuse, that is AB, then from the other triangle, I need to take the hypotenuse, AC. So see, ratio of their corresponding sides. Hypotenuse will always correspond with hypotenuse. Is it okay? So from these two triangles, if I take the hypotenuse from the first triangle AB, then from this triangle also, I need to consider the hypotenuse, that is AC. So because hypotenuse always corresponds with hypotenuse. So ratio of their corresponding sides will be equal to the ratio of any other corresponding sides again. From this right triangle, this AD is your base. This AD is your base. From this right triangle, okay, from this right triangle, AB can be your base, BC can be your base. If this is the hypotenuse, this can be the base, AB can be the base, or BC can be the base. You can take any one of them. But let me choose AB as your base, so that next time you choose BC as the base. Alright? So, okay, from this right triangle, if I choose the base AD, then base should always correspond with base. Then I have to take AB on the other triangle. So ratio of the hypotenuse, here this is the ratio of their bases. So the ratio of their corresponding sides must be equal. Now if you cross multiply AB into AB, AB square is equal to AC into AD. You can make this as equation number 1. You can make this as equation number 1. Alright? Now what I'm going to do, I'm going to take, next time, I'm going to take the next smaller triangle BDC and the bigger one ABC. So now what I'm going to do is, I'm going to take the other smaller right triangle BDC and the bigger one ABC. Alright? They are already similar, right? So I'm going to draw them. BDC. This is how your BDC looks like. This is how your BDC looks like. where this D is your 90 degree, and the bigger one ABC. The bigger one ABC, okay, the bigger one ABC, the bigger one ABC with angle B as 90 degree. So I'm going to take these two right triangles. Now we have already seen that they are similar. Now in triangle BDC, or you can write, since triangle BDC is similar to triangle ABC, we have already seen they are similar. So here also, their corresponding sides will be in proportion, meaning ratio of corresponding sides will be equal. So from this triangle, if I take the hypotenuse BC, then hypotenuse always corresponds with hypotenuse, right? In this right triangle, your hypotenuse is AC. So hypotenuse will always correspond with hypotenuse. So BC upon AC will be equal to the ratio of any other corresponding sides. From this triangle, your base is CD. From this triangle, you can take AB as the base, you can take BC as the base. In the first case, we took AB as the base, so why don't we take BC as the base now? So from this smaller triangle, your base is CD. From the bigger one, your base is BC. Now, if you cross multiply BC into BC, BC square will be equal to AC times CD. AC times CD. That is equation number 2. That is equation number 2. Now what I'm going to do is, I'm going to add the above two equations. I'm going to add equation 1 and 2. So whenever you add two equations, left-hand side should always be added with left-hand side, and right-hand side should always be added with right-hand side. Is it okay? Left-hand side should always be added to left-hand side. So adding equation 1 and 2. So if you add two equations, the left-hand side of the first equation should be added with the left-hand side of the second equation, which is equal to the right-hand side of the first equation, AC into AD, should be added with the right-hand side of the second equation, AC into CD. Now you see, class. Look at the right-hand side. This is your first term, AC into AD, and this is your second term, AC into CD. From these terms, what do we have in common? From these two terms, what do we have in common? We have AD in common, right? We have AD in common. Or we have AC in common. We have AC in common. So you take AC common. Okay? So if you take AC common, then from the first term, we have AD. And from the second term, we have CD. If we take AC common, from the first term, all we have is AD, plus from the second term, all we have is CD. Now AC into, now look at your figure. Look at your figure and tell me, what does AD plus CD gives you? Please comment on the chat here. Look at the figure and tell me, what does AD plus CD gives you? Look at your figure and you can please comment, what does AD plus CD gives you? AD plus CD gives you, yes, only one student comment, that's one row. So AD plus CD gives you AC. So AC into AC will be now AC squared. AC into AC will be now AC squared. So what we have proved is what we have proved is, so what did we prove here? AB square plus BC square is equal to AC square. So what did we prove? We proved that square on the hypotenuse is equal to the sum of squares on the other two sides. So we have proved that the square on the hypotenuse is equal to the sum of squares on the other two sides. Look here, what did we want? This is what we wanted to prove. So we have proved that AB square plus BC square is equal to AC square. Look here, AB square plus BC square is equal to AC square. So, and this proves the Pythagoras theorem. This proves the Pythagoras theorem. Is it all right? Is it clear with you? So this is a very important theorem for the examination point of view and for solving chapter 6 problems. So I want you to make a proper note and copy this proof of Pythagoras theorem. Is it okay? Yes. You can take your time doing that.